Okay, so what if I told you that the very dimensions of our reality, the space we actually move through, are all generated by one single, incredibly simple rule, a hidden law of order? Well, in this explainer, we're diving into some fascinating research that argues exactly that. This right here, this is the whole game. This one sentence is the core idea. It's saying that we don't just start with some pre-existing space. No, we build it. We generate it out of this property called non-commutativity. So what on earth is that? Don't worry, that word sounds way more intimidating than it actually is. In fact, it's a principle you deal with every single day of your life. Let's make this really intuitive. All non-commutativity means is that order matters. That's it. Think about it. If you put on your socks and then your shoes, everything's fine, right? But if you try to put on your shoes, then your socks, you get a very, very different result. The order of operations changes the outcome completely. Or take a look at this physical example. Grab a book. Rotate it 90 degrees forward, then 90 degrees to the right. See where it ends up. Now reset it and do the opposite order. 90 degrees right first, then 90 degrees forward. It ends up in a totally different orientation. That difference, that little gap between where you expected it to be and where it is, that's non-commutativity in action.
And this is the central question the research tackles. If just changing the order of simple rotations creates a different physical result, what does that really imply about the fabric of space itself? This is where the answer gets truly mind-bending.
So now, let's actually visualize how this works. We're going to see how this simple rule of order nattering doesn't just change where an object is pointing. It literally carves out geometry from nothing. Imagine you're walking on a perfectly flat grid, like a giant chessboard. You take one step forward, one step to your left, one step back, and finally one step to your right. What happens? Well, each move perfectly cancels out its opposite. You end up exactly where you started. On a flat surface, the path closes perfectly. The order doesn't create any lasting effect. Okay, but now let's run that exact same sequence of moves, but this time on the surface of a sphere, like our planet. You walk forward, turn left, walk back, turn right. And this time, you're not back where you started. There's a gap. The path didn't close. Why? It's because on a curved surface, the operations of moving forward and moving left don't perfectly commute. Their order creates a real, lasting geometric effect, a literal gap in space.
And that gap, believe it or not, has a name. It's called holonomy. And it's not some kind of error, it's a piece of information. This is so important. The size of that gap is a precise measurement of how curved the surface is. If there's no gap, there's no curvature. A big gap means a whole lot of curvature.
All right, so we've got this intuitive idea. When order matters, you get a geometric gap. But how do you actually write that down as a law of the universe? Let's get to the mathematical heart of this paper.
This is how physicists and mathematicians write the gap. It's called the commutator or sometimes the Lie bracket. It's really just a simple operation that takes two actions, let's call them A and B, and it calculates the difference between doing A then B versus B then A. If the order doesn't matter, this thing, A comma B, is just 0. But if order does matter, A comma B is non-zero, and its value tells you exactly how much it matters.
And there it is, the central identity. This equation is one of the most elegant and profound things I've ever seen. It says that the amount of geometric curvature you experience from two actions is identically equal to their algebraic commutator. The physical world of shapes and curves is a direct mirror of this abstract rule of order. The geometry is the algebra. Okay, get ready for the big payoff. We've talked about all these different pieces: order, gaps, curvature, math. Now we're going to see how they aren't just related. According to this research, they are literally the exact same thing, just viewed from different angles.
This table just lays it all out beautifully. Here's the logical chain. If the order of your actions matters, then mathematically you get a non-zero commutator. We just saw that a non-zero commutator is curvature. That curvature is what creates the gap, the holonomy, and that gap encloses a tangible, measurable area. And here it is, the final leap. If you have an area, a little two-dimensional patch of space, you have forced the existence of a new direction to move in. You have literally created an emergent dimension.
It all starts right here, with the simple algebra that asks, does order matter?
Which then shows up in the physical world as the actual warping and bending of space. This creates a tangible loop, a measurable patch of surface that wasn't there before.
Which finally defines a new independent direction.
A brand new dimension born from nothing more than the simple fact that doing A then B isn't the same as doing B then A. Wild.
And look, this is not just some beautiful abstract math. This master rule pops up everywhere, from the deepest quantum mechanics to the robotics and data science we use every day.
I mean, this exact same mathematical structure, this AB, determines the phase of a quantum particle as it travels in a loop. It's what governs how a robot arm or a character in a video game rotates in 3D space. It even describes the hidden structure of data in signal processing. It is a truly universal principle.
Let's just take that signal processing example from the paper for a second. Imagine you have a signal. If it's just a simple, one-dimensional wave, the math shows it has no area. But the instant you introduce a second wave that's just a little bit out of sync, they combine to create a two-dimensional loop. The math confirms it by showing that the area enclosed by that signal's path has literally forced the system into a second dimension.
So we come all the way back to this idea. This one statement really does summarize everything. The rich, complex, geometric world we live in isn't the starting point. It's just the consequence of a very simple, very fundamental rule about the order of events.
And that's the thought I really want to leave you with. If the sequence of physical movements can literally build space itself, what about the sequence of our choices, our thoughts, our interactions? What unseen geometries are we generating every single day, just by the order in which we do things? It's a pretty fascinating question, and it shows just how deep this simple rule of order really goes. Thanks for watching.